that we can discuss time also as an axis, as a variable. Huh? Einstein, I mean, there are so many stories that how did he understand this, or how did he came up with this concept. But Einstein at some time understood that time is also can be plotted on an axis. So when there is an event, now first thing is that what do you mean by an event? Now, event can be anything. It can be my blinking of eye. It can be a lightning. It can be a ticking of the clock. Huh?
Mm.
Now I have so many events happening around me. Hmm? Now
Yeah.
in this room, everything is at rest with respect to me. Hmm? So
Yeah.
whatever I measure here, it is in the rest frame. Hmm? I can give every event a position, and I can give every event a time. Hmm?
Yeah.
To make the thing simple, in your level, I mean at IB level, we are assuming a one-dimensional thing, I mean one-dimensional motion. That means we are only talking about the variation, the motion in x direction. We are not talking about a variation or the motion in y and z. So we are totally ignoring y and z. Hmm?
Mm. Yeah.
Why we are ignoring? Because of simplicity. अभी x को समझ लेते हैं. Then later on, in high levels, you also can be asked to discuss the x, y, z coordinates together. Hmm?
Mm. Uh,
Now come back. So suppose there is a lightning strike somewhere. So you can read the clock at what time it happened, and you can mark the position where it happened on X. So there
yeah.
are two coordinates that we are noting down. One is the time, one is the position. Okay? We are not noting down Y and Z. Now, if the same event can be seen by two different observers, हाँ? तो क्या होगा? जैसे फॉर एग्जाम्पल I've seen the second ये जो diagrams मैंने बनाए. Now it is possible that there is a man A. huh? This man A, he is sitting at one point and he is watching the tree. Now this man watches the tree at t equal to 0. He watches the same tree at t equal to 1 second. Then he watches it at 3 seconds, 5 seconds, 10 seconds. Huh?
Mm. Yeah.
Every time he is measuring x, because obviously tree is not going anywhere. So the distance is x, x, x at every time. On the other hand, there is a man B. He is moving, and if he is moving with the velocity b, then in the 0th second, he will also measure the time as the distance as x. Hmm?
Mm.
But 1 second later, hmm, so in 1 second later, he will measure the distance as x minus v. है ना? क्योंकि थोड़ा सा he went forward. After 2 seconds, he will measure x minus v times 2. Isn't it? He's coming closer to the tree all the time. So his distance from the tree, his observation of the tree will keep on changing with time. Yes. So what
Yeah.
will he measure? His value for the position of the tree is x dash equal to x minus dt. Hmm?
Mm.
Till this point, is there a doubt?
No.
This was Galileo's discussion. This much Galileo understood. Ki bhai, if there is a person who is sitting and if there is a person who is moving, they will both not see the position same. They will see it different. But Galileo never thought this same thing or this relativity can be applied to time. So he said, कि भाई, if the event occurs and somebody is noting down the time, then time will be noted down by both of these people as the same. दोनों सेम ही टाइम नोट करें, है ना? अगर अगर वो कह रहा है कि it happened at 1 minute, so other one will also say it happened at 1 minute. Movement has nothing to do with time.
Okay.
That was Galileo. Galileo अपने टाइम को he didn't touch. Then Galileo's relativity about velocity, law of addition of velocity. Here I have shown there are two different frames. One is a frame in which there is a train. I'm imagining a train. And that train is moving forward with a velocity v. Yes. And in this train, this man, he kicks the ball with a velocity u dash. Okay.
Okay.
Moving frame is generally shown as u dash. Okay.
Okay.
U dash. And there is this man, he is standing here. अब ध्यान से समझना. Okay, this is very confusing. This man inside the train, he notices the velocity of the ball as u dash. This man on the land notices the velocity of the ball is u dash. Oh, sorry. He notices the velocity as u. Okay. So if I know my logic, then u should be equal to u dash plus v. Correct?
Yeah.
To this man A, this ball will appear to be moving at the speed of u dash plus v. Because उसके लिए तो train is also moving. Ball is also moving in forward direction. So for him, the ball is moving faster.
Yeah.
So you can say u dash, that means the velocity for the man inside the velocity of the ball inside the train appears to be u dash. Is it clear?
Yeah.
Okay. Next. Next. If we use Galileo transformation, now Galileo ने तो दे दिया, he did it, everything he did. But if we use Galileo's transformation for light, then light speed will depend on the state of motion. Say again.
Yeah.
Is it right? कैसे state of motion? Say there is a spacecraft which is traveling forward with a speed of 0.8. And instead of a ball, you have a torch, light. Okay. And you send a signal of light with a velocity c. So as per the Galileo's logic, if I see it from the ground, then what should I see? I should see u is equal to u dash plus v. Isn't it?
Yeah.
उस हिसाब से the value should be 1.8 c. But as per Maxwell's electromagnetic theory, the speed of light in every frame should be same. Maxwell ने बोला कि नहीं? Of course. The speed of light is same in every frame. Everywhere it is the same. Now, Einstein had two options. First option was he should believe believe Maxwell and should not believe Galileo. And the second option is that he should believe Galileo and not believe Maxwell. Now Newton ने कुछ सोचा होगा, but maybe he was like more satisfied by the Maxwell's work. So he believed Maxwell and he didn't believe Galileo. He said Maxwell's theory is correct. Speed of light is same in every frame. That means we have to change Galileo's theory. Yes, Shivani?
Yeah.
Makes sense? कि भाई, one is predicting this. I have no proof, I have no way of checking. हाँ? दोनों अलग अलग जवाब दे रहे हैं, तो किसी एक one must be believed. Einstein believed it, and so he said, let us vary the Galileo's relativity formula. Then he gave these postulates. You can read these postulates. Read. Have you read?
Yeah.
The first one says that the laws of physics are not only same in, law of Newton are not the same everywhere. All laws are same in every inertial. Yeah. The second postulate is the speed of light is same in all inertial frames. Okay. From there, he got these formulas. We don't have to prove these formulas, so I'm not proved it. Just written. See carefully. Einstein K, I have given two formulas. One with reference to the person in motion, and one from the reference of person at rest. Yes?
Yeah.
Now, if V is very less as compared to C, matlab, I'm talking about my car. है ना? So my car though is moving very slow as compared to anything else. है ना?
Yeah.
So the gamma will be approximately equal to 1. This gamma is known as Lorentz factor. Yeah? And if I draw a graph for Lorentz factor, I see that initially it is 1, 1, 1, 1, and then it increases and goes to infinity actually. Okay?
Yeah.
Infinity. So for very small velocities, we do not have any value for gamma. It is 1. Okay? चलो, पढ़ो जरा अब इसको 1 मिनट के लिए. ये देखो क्या लिखा है. I have written some common assumption which I will always be following. Okay? I will not write them all the time, but these assumptions are always there. Okay? What are the assumptions? We will denote S as any inertial frame and S dash as the frame moving to the right relative to S. ये ध्यान रखना that nobody told you that S is at rest. किसी ने नहीं बताया. ऐसा किसी ने नहीं बोला that S is at rest. I am saying S is any frame because perfect rest is not possible. There is nothing in this world which is at perfect rest. Yeah?
Okay.
So, if we have any frame, and there is another frame which is moving with respect to me, then that is called S dash, and my frame is called S. Okay?
Mm. Okay.
Read the next two lines. You can read it loud. Read it loud.
Okay. Clocks in both
Clock in both frames.
so 0 at t is equal to 0.
Mhm. And their origins, what?
Coincide. X is equal to 0.
That means when we started the process, the two frames were together. Yes, they were at the same position, at the same place. Time was also matching. दोनों का time भी match कर रहा था. Everything was matching. These two things we will take as common assumption everywhere. Okay. Now read the
Okay.
question. The event is occurring at 5 seconds.
Hmm.
The position is 3500. You have to find when and where it was recorded by the rocket moving at 0.80. So इसका मतलब rocket is S dash, and the event itself जिस frame में हुआ वो S. ठीक है?
Okay.
यहाँ पे हुआ and rocket is going past. The rocket is S dash and this frame is S. ठीक है? Now, what is T? T is 5 seconds. Achha, gamma, first of all, you found gamma. Gamma, you found 5/3. Now, see carefully. Check the calculation. If there is anything that seems off, enough. Right? What is T? 5 seconds.
Yeah.
What do you get? 8.3. ठीक है?
Okay.
8.3 seconds means that the rocket will measure that same event a little later. Yes? तो उसके लिए time is going slower if you notice. है ना?
Yeah.
उसको wait thing, that thing appeared a little later. So his time is slower. ठीक है? Right? We will talk about. So observers cannot agree on this. एक ने ये नोट किया, दूसरे ने दूसरा नोट किया. How do I know कि they are right or wrong? Like I'm saying you are wrong, he is saying I'm wrong. So how to judge? Read it. The Einstein noticed that while time and space are not absolute, there are some quantities which never change from frame S to S. And these quantities are called invariant. Okay? Invariant. Right? Now,
Yeah.
invariant quantities there are three quantities. One is called the proper time. Second is called proper length. And third is called space-time interval. This is proper time. That is the time as noted, time measured when measured in the frame where the events are at the same place. It's not easy to understand. What do you mean by at the same place? Means it is at rest. Yes. Just say, for example, if I I take this clock. I have a clock in my phone, and I look at it, and this reads 4:10, and then after some time it reads 4:11. So this difference in the time is 1 minute, and that is the proper time for me. Abhi aaj, if I note it now or I note it later, it does not matter. Okay? But if the same time in my phone, whatever the time is, somebody is looking from somewhere else. ठीक है सोचो जरा ध्यान से. This is my phone. It's showing 4:10. There is this man here. Hmm? And he is coming, let's say, towards me. Hmm? So he was at some distance, light leaves this point, reaches him, he notes down 4:10. Next 1 minute later, he's not at the same position. He's somewhere else. His distance from the clock has changed.
Yeah.
If his distance from the clock has changed, then the distance traveled by light is also changed.
Mm.
So it is possible. When he notes down here and there, the time difference may not be 1 minute exactly. It will be more than that.
Yeah.
Yes, it will be more than that because velocity of light has to be the same. अगर आप इधर ये लाइट आ रही है यहाँ से, ये आप इधर आ रहे हो, इसका मत देखो, सिंपल सी बात है, मैं कैसे समझूं? बहुत ही सिंपल बात है लेकिन देखो, if ये this is the man and this is light coming towards you. पहला observation he took here and second observation he took here.
Mm.
या अगर ऐसा होता कि the speed of light is also dealt like the normal things, then the two things they must have added, the relative velocity would have been c plus v, and the time would have remained the same. Yeah.
Mm.
But because c cannot change, c तो सेम नहीं रहेगा, कोई फर्क नहीं है. तो इस that means when this person is moving forward, the c remains the same. c यहाँ पर भी वही है, c यहाँ पर भी same है. तो due to his own velocity, whatever difference he is looking at, the time will change. Understood? The
Yeah.
distance traveled by him is equal to velocity multiplied by time. है ना? अब आप
Yeah.
कह रहे हो कि velocity तो change ही नहीं हो सकती है जी, this is the constant.
Mm.
ये तो change हो ही नहीं सकती है. So that means who has to change? Time has to change.
Yeah.
है ना? अगर वो आदमी वहीं का वहीं होता तो मतलब डिस्टेंस सेम होता, और अगर ही इज मूविंग तो भी डिस्टेंस सेम है, बट वेलोसिटी यू आर सेइंग की चेंज नहीं हो सकती. तो व्हाट हैज टू चेंज? द टाइम हैज टू चेंज. अच्छा, दैट इज द लॉजिक.
Mm.
ओके.
Okay.
I don't know how much I could like drive home, but the thing is that as soon as you say that the speed cannot change and the things are changing, तो किसी को तो change होना पड़ेगा. And we come to know that it was it was the time that changed. कहाँ थे हम?
Mm.
I was talking about this. ठीक है? खैर, anyways, the proper time की बात हो रही थी, wherever the object is at the same place. हाँ? And proper length is whenever the time is the same. Proper length is again in the same frame where the object is at rest. This is a special quantity जिसमें you specifically have been given this value. That means if you want to check that your answers are correct or not, you can check it like this. See, initially 5 seconds था time, later on 8.3. ठीक है? The
Mm.
time became 8.3 from 5. Initially the distance was 3,500. Now it has changed into minus 10 to the power 9. If you equate them, they are equal. This is an invariant. You can use it to find. See, so if there are four things in it, है ना? There are four things in it. One is delta T, delta X, delta T dash, delta X dash. Four things.
Hmm.
है ना? अगर if I write it down, so it will be C delta T square minus delta X square is equal to C T dash prime whole square. How many variables are there? Four.
Yeah.
Out of which, if you know three, fourth one you can find out. है ना?
Yeah.
Next. So we can prove that they are equal. So that means this is a correct. Now let's do one more question. Read. So there is a rocket which is moving at 0.8 C past a space station. Where is the rocket according to the space station when the rocket clock shows a 0.6 microseconds? Yeah.
Hmm.
0.6 microsecond. Now, in this case, you will notice that X dash is 0. है ना? The clock in the rocket is stationary. No change in its position. Yes?
Yeah. Yeah.
So you can say X dash is 0. The velocity is, velocity is how much? 0.8 C. Hmm? Gamma, we have calculated 5 by 4 in this. 5 by 4 already calculated. So 5 by 4, you can do this. 5 by 4. Huh? And T is time. Time is how much? T dash is 6 microseconds. Correct?
Yeah.
तो आप इसको कैलकुलेट कर सकते हैं. This is gamma 5 by 3. X dash is 0 because the clock inside the moving spacecraft, inside the rocket, the clock was at 0 only. There is no change as per that place. Plus, what is the velocity? 0.8 C and T.
Oh my.
T is 6 microseconds.
Hmm. Yeah.
And you calculate this is 2. Okay. Now, if you do this, the same thing here, again, X dash is 0. So T is equal to gamma times T dash. T dash is this much.
Hmm.
And you'll get 1. Okay.
Yeah.
Again, if you want to check, you can check using the value. Okay.
Okay.
Now come to the effects of relativity. Yeah. Read. So there is a man in the frame of reference S1. Okay.
Hmm.
S1 नहीं S prime. S prime. He measures the time between two successive ticks of the clock. Tick, tick. Huh? Clock is at rest in S dash, S prime. So the ticks occur at the same place. है ना? Ticks are occurring at the same place.
Hmm.
So what
Yeah.
can you say? What is the difference in the position of the two events? 0. What is the difference in the position of the two events?
0.
0.
Yeah.
The time interval as seen in the moving spacecraft or the rocket is delta T dash.
Hmm.
The man in S will measure the time delta T. So what will you get? This? Yes. So
Yeah.
delta T will be greater than delta T dash. Matlab that in the time in which the spacecraft clock measures 1 minute, the clock on the Earth or as seen from Earth, the time in the clock will take more time. मतलब यहाँ से यहाँ जाने में ज़्यादा time लगेगा. Do you understand?
Hmm.
मतलब the person who is sitting in the rocket तो he will count 1 second, 1 minute,
Yeah.
है ना? 1 second or 1 minute, हाँ? But the person who is sitting on Earth, he will see it as 1.2 seconds.
Hmm.
I'm just giving one example. He will
Yeah.
measure it as a little more. ठीक है? तो
Yeah.
according to him, he will say that the clock in the rocket is slower. है ना?
Yeah.
And he will say that the clock in the moving rocket is slower. This is
Hmm.
called time dilation. Yes.
Yeah.
So, according to the person who is sitting, वो बोलेगा कि 1 साल हो गया, ठीक है? Who is sitting inside? The person who is sitting on earth will say नहीं 1.5 साल.
Hmm.
One more than one, है ना? तो बोलेगा नहीं भाई ज्यादा टाइम हो गया. ऐसे ही बोलेगा.
Unless
It's
I don't
not.
understand Hindi.
बेटे अच्छा you don't understand. Sorry. Okay, so I was saying that the person who is sitting on earth, he'll say no, it's more time. It's not 1 year. It's more than 1 year, isn't it?
Yeah.
Because he's watching, and whenever there is 1 second in that frame, it's 1.1 second in my frame. So
Hmm.
every 1 second, 0.1 keeps on adding. So what will I say at the end of the 1 year? Ki, no, your 1 year has gone, but my 1.3 years have gone, or like something. Fine?
Hmm. Yeah.
Delayed, time delayed, dilation. Fine?
Yeah.
Now you can read this. The time measured in S dash is special. Yeah, as the two events take place at the same point in the space. So the time interval in S dash is called the proper time, just like I was saying, telling you that the time measured at the same place
Yeah.
is called the proper time. Yeah.
Hmm.
If you measure one tick here and one tick there, it's not proper,
Yeah.
right?
Yep.
So the man who is on earth, he's not measuring proper time. चलो आगे चलें. Next one. Next thing is, can you read this example? The half-life of a substance as measured in a lab is 2 minutes. Calculate the half-life as calculated by a rocket moving at 0.85. So this time I am on earth. I am in lab.
Hmm. Yeah.
And if I am in a lab, I am looking at the same event at the same place.
Yeah.
So my time is the proper time. Yes.
Yeah.
And what will he see from the rocket? Yes. Yes.
Yeah.
Next. Read about GPS. Do you know about GPS? What is a GPS? It's a what do you call it? Full form. Do you know that? Global positioning system.
Okay.
Yes.
Yeah. Hmm.
So if you want to work with the GPS, you have to be in coordination with the signals coming from the satellite. There cannot be any mismatch. The signals are to be sent directly to that particular place. If there is any change this way or that way, the GPS will be useless. Now the
Hmm.
thing is that GPS is moving at the satellite is moving at 4 kilometers per second. Yeah, in the space
Hmm.
orbiting. It's not much, but it is not that small also. Kilometers per second, remember. Okay.
Yeah.
So when we find gamma, hmm, we find gamma as 9 into 10 raised to power minus 11. Yeah.
Yeah.
Now, if this is the value, and if there are 86,400 seconds in one day,
Hmm.
hmm, then
Yeah.
what will happen? Due to this small change, hmm, how much change will happen in one day? 8 microseconds. Yeah.
Hmm.
And
Yeah.
8 microsecond in terms of the speed of light are 2,400 meters. Yes.
Yeah.
That means there will be a change or uncertainty, of 2,400. That much error, useless.
Hmm.
GPS becomes useless. So the GPS is corrected, the timings, the match is corrected for this relativistic error after every hour. Okay.
Hmm.
So that there is no mismatch and the position is certainly known. Correct?
Hmm. Yeah.
Anything you want to ask?
No.
Next. So length contraction. Let's talk about contraction of length. So if you will have a length, if you have a rod and it is placed in your rocket, you are going in a rocket and the length of the rod is placed in your rocket. Now, it is not necessary to measure the two sides of the rod together. Is it necessary? No.
No.
You can measure this one and then after 1 second, you can measure the other side because you are sure that this rod is with you. It is at rest with respect to you. It's not going anywhere. So you can take any time to measure one side and the other side. No problem. So delta T dash is not zero this time. Okay.
Hmm.
Earlier delta T dash was zero. See? No, delta X dash was zero. Okay. In this case, delta T dash is not zero. On
Yeah.
the other hand, if you are in a moving place, moving thing, then if you may take the reading of one side one moment and the other side you are taking other moment, so till then so the whole thing will move forward and other side will go somewhere else.
Hmm.
So you have to take the value together. Yes.
Yeah.
So delta T is zero. Yes.
Yeah.
Delta T, that means when we take it from a moving object, from where the rod is moving, okay? The place from where the rod is moving, that delta T should be zero.
Hmm.
If delta T is zero and delta X, the new length in that moving frame, is L. Remember, one more thing. Because you are not going anywhere, in the frame of the rocket. I'm in the rocket. This is my mobile phone. The length that I measure for this mobile phone is the proper.
Mm.
The length in the frame where the mobile is at rest.
Yeah.
That is proper. So this one is the proper. Yes,
Yeah.
it's written. According to that, what is L? L naught divided by gamma. And
Mm.
that shows a contraction of, okay? Yes.
Yeah.
Next, consider the frame S dash that moves with the speed v, and S at rest. There is a frame S at rest, and there is a frame that is moving at u dash. In Galileo hypothesis, we just write this, but in Einstein's equations, or sometimes it is also called Lorentz equation,
Yeah.
the velocity is like this. You don't have to see the proof. You will be given in the data booklet.
Yeah.
Now, if I see this, read the question. There is a rocket which is moving at 0.8.
Mm.
There is a missile fired from there at 0.5. If you follow the Galileo's logic, no, if you follow the Einstein's logic, अच्छा,
Yeah.
please इसको ध्यान, just you read it carefully and you tell me, is there anything that you don't, मतलब, you don't approve, or you think I don't know what this, I don't understand why you have taken this as this. What is V? Remember, in the beginning also I have shown you such a thing. Yeah, this one. V is the velocity with which the train is moving. U dash is the velocity, the ball as seen by this moving person,
Mm.
and U is the velocity as seen by the stationary. Same thing.
Yeah.
Yeah, yes. See, does it make sense?
Yeah, it will if I like put it in my calculator.
Yeah.
Yeah.
That,
Yeah.
so it is less than C, no problem. But if we use the Galileo,
Yeah, it's more than the
this is
speed
a
of light.
value, which is not.
Not possible. Yeah.
Next, simultaneous. When do you see the two events together, simultaneous, and when do you see them at two different times? So, assuming two frames again, S and S dash as prime, if two events take place at the same time in frame S dash, suppose in S dash, the events took place at the same time, then delta T dash should be 0, no
Mm.
difference in time.
Yeah.
Simultaneously they took. So if delta T dash is 0, then this relation. See,
Oh, are these all in like the data booklet?
if they don't give it now, so you're dead.
Yeah.
Then you'll have to mug it up. I don't think that is the case. I've not checked, but I'm 99% sure that they will give you these relations. Okay, if they don't give, then you have to memorize. There is no other.
Yeah.
Yeah. So delta t dash is 0. If delta t dash becomes 0, what is delta t then? This whole thing. Yes?
Mm.
What do you understand by this? You understand that if delta x dash is not 0, then the events will not be simultaneous in frame S dash. Yeah.
Mm.
They will not be simultaneous. I have taken two different, firecrackers. One I place here, one I place here, and I, ignite them together. Okay. So if
Mm.
I'm here inside this room, both are simultaneous. Huh? But if I am moving outside, then these two may not be at the same time.
Yeah.
Why? Because again, you can think of that the light takes a different time to reach. Light takes a different time to reach. Light you cannot change. Huh? Speed of light you cannot change. So
Mm.
what you'll have to change? Time.
Time. Yeah.
No, this light reaches a little later. This light reaches a little first. I mean
Mm.
earlier. If
Yeah.
you calculate this thing, I mean, if you say that, oh, you are moving away, so that is why the velocity added, so that is not allowed. That is not allowed that you cannot change the speed of light. So what will you say that, oh, this time is less than that time is more. That is why this is reaching later. Understood?
Yeah.
Hmm. But if the two things are happening at the same place, then the event will be simultaneous from every position,
Yeah.
from all the frames.
Mm.
Okay? Simultaneity. Now, this is a very important example, mu1 decay. To say is very easy, but how to prove it? No?
Mm.
Einstein said so many things, so many weird things, but then he had to prove it. Huh? So this is the proof of relativity. There is a particle that is called muon, and they're very unstable, so they convert into electrons.
Mm.
They have a half-life of average life of about 22.2 10 to the power minus 6 seconds. They're traveling approximately 0.99 C. So according to that, they should travel approximately 605 for 650 meters approximately 1 kilometer next. That means if they are created at the top of the mountain, then they should be detected up to 1 kilometer maximum and should not be detected at the bottom of the mountain. Yes,
Yeah.
because they should convert into electron already. Huh? But when the experiments were done, it was seen that muons can be detected at the sea level about 5 kilometers, 5,500 meters down, 5,000 meters down, right? About 5 kilometers below also, we could actually detect muons, some muons. I mean, obviously, not all of them, but some muons were detected. This
Mm.
was so strange. How is it possible? The answer is that because the muons are traveling at a hmm, very high speed
Yeah.
they are traveling, so their time is dilated. Okay, their time dilated, and it became this. Okay?
Mm.
Can you read it? Read it yourself. I will give you half a minute.
Mm.
This proved that due to motion, these muons, they had a longer lifetime. Hmm? They were moving, so they had a longer lifetime, so they could reach the surface of Earth. Yeah.
Yeah.
This is, you can say, two-third complete. Yes.
Mm. Yeah.
Now comes the space diagrams. This is a whole new thing. Huh? And I think we should start it next time. Yes.
Okay.
Till then, I will send you some work. You can do some questions
Yeah.
about the relativity, spontaneity, time dilation, etc., etc.
Yeah.
And next time we will start from the space diagrams. Fine.
Okay. Yeah.
Okay, see you
Okay.
then.
Thank you.
Bye.
Bye.